In this video, we will be looking at two examples of solving log equations where you need to condense two logs together first before you can start solving. So let's start. So we have to solve this equation. Log base 2 of x minus 4 plus log base 2 of x plus 3 equals log base 2 of 18. Before we can even start solving this, I want to point out that since the x minus 4 is inside of a log and the x plus 3 is inside of a log and the 18, it's just a constant, is inside of a log, there's nothing else in this equation outside of a log that we can use the one-to-one property to solve this. So we'll use the one-to-one property. To solve this equation. Now, how are we going to be able to get to use that one-to-one property? We can only use it if we have a log equaling another log. And right now, we have two logs on this side. So we need to condense them before we can do anything else. So if we condense those two logs together, we get the log base 2 of x minus 4 times x plus 3 equals the log base 2 of 18. Now that we have a log equaling another log, we can go ahead and, you students like to say, cancel the logs. So that just leaves us with x minus 4 times x plus 3 equals 18. All right. Well, this feels like it's going to be quadratic because I have a binomial and another binomial, so I should FOIL this out. And this is definitely quadratic at this point. So in order to solve something quadratic, we need an equals 0. So I'm going to go ahead and subtract this 18 from both sides. There we go. This gives me x squared minus x minus 30. So now I can go ahead and factor. That gives me x minus 6 times x plus 5. And I got that by factoring. Now I can go through and say x equals 6 and x equals negative 5. All right. So as you must do when solving all log equations, you must check your answers. So here I have x equals 6. So if I take this and I go all the way back to the original equation, right here, and I put 6 in for this x, then I'll have 6 minus 4. 6 minus 4 is 2. That means this inside this argument becomes 2. That makes this a positive argument, so far this answer is checking out. We have to check to make sure all the logs within x have positive arguments when we substitute 6 in. So when I take 6 and I substitute it into this argument, 6 plus 3 is 9. That's a positive number. It's inside the log. Check. 6 is a good answer because it makes the arguments of all the logs positive. Now I didn't have to check this one because this did not have an x in it. This is already a positive argument. We are good to go on that last log. Let's take a look at x equals negative 5. If I take negative 5 and I substitute it in here for this x, negative 5 minus 4 more is negative 9. The argument when I substitute in negative 5 is negative 9. We're not allowed to have negative arguments in our logs. This answer doesn't work. Our only answer here, x equals 6. In this example, we have, oops, I see something I missed. All these logs have base 91. There we go. Now, this example looks really similar to the last one. First, I want to point out that everything is inside of a log, so we will use the one-to-one property again. But this time we have subtraction. And when you have subtraction in your condensing logs, positive log arguments will go in the top, negative log arguments will go in the bottom. So let's see what we can do here. When we combine these two logs together, we'll get the log of 91, or log base 91, of x plus 2 over 3 minus x. And that will equal the log of 91 of 4. Well, now that the logs, we have one log on each side, and in fact they have the same base. That means we can chop the logs. And that just leaves you with an equation, x plus 2 over 3 minus x equals 4. Now this equation's a little different. We have a rational equation here. That means I want to multiply by the LCD. And in this case, it's just 3 minus x. So there's an LCD, it's 3 minus x. Multiply both the left side by 3 minus x and the right side by 3 minus x. And so that's going to leave me with this. There we go. The denominator cancels with the LCD. And then we have 4 times 3 minus x here. And so then you can distribute this out. We can add 4 x's to both sides, like that. And then we can subtract 2 from both sides. And then we can divide both sides by 5. Running out of room here, and that'll give you x equals 2. So then the very last thing we need to do is check to make sure that all of our arguments with x's in them are positive. So I'm going to take this 2, I'm going to put it in for this x here. 2 plus 2 is 4. That's a positive number, so the inside, the argument of this log is positive. And I'm going to take that same 2, and I have to check all the logs with x's inside, so this one too. 3 minus 2 is 1, that's positive, this argument is positive. Man, that means this answer is good. All right, I hope these 2 examples help out.